Low-temperature thermal decomposition. One green step. A giant leap towards zero waste. Present practices for MSW are door-to-door collection, transfer station, segregation at source, recycling plant. By 2048, India will generate 125 million tons of MSW, making it the largest waste contributor in the world. That needs the enormous size of landfills. Even scientific landfills are having environmental issues of GHG emission, transportation, Low-Temperature, space requirement, air pollution, etc. Segregation at the source is a good approach, but there will always be environmentally conscious people who will unintentionally throw away objects improperly. Decentralized units are not feasible. The increasing percentage of hazardous e-waste in MSW needs to be addressed. For active landfill truck traffic space, secondary contamination, high operation cost, litter and dust, odor, increasing 500 feet/year, can't destroy e-waste, major source of GHG emission, Low-Temperature and groundwater pollution, loss of property value, vectors, vermin, and nuisance organisms, can't receive medical waste. For incineration process, high capital cost, small setup not feasible, creates pollution, leading source of dioxins as per UNEP. Operation cost is very high. Fly ash disposal is costly practice. For biogas plant, only biodegradable organic waste can be disposed of. Depends on the landfill. Slow process and needs careful operation for optimum performance. Need of the hour. Low capital and operation cost, decentralized units, minimum human interaction, destruction of pathogens, lowest energy utilization, no odor, no Low-Temperature and water pollution, lowest carbon footprint, mobile unit, use of renewable energy. The best option is to follow 3R, reduce, reuse, recover, and dispose the unavoidable waste scientifically. This practice will take time to adopt and it is very difficult to implement for biomedical waste. We are disposing our waste away from our home but into the environment, which is limited and common to all. The amended rule suggests an offset mechanism, even under extended producer responsibility, for both the producers and brand owners under Plastic Waste Management Rules 2018, Ministry of Environment and Forest and Climate Change, which says the amount of equivalent plastic and packaging that the producers and brand owners are able to recover and recycle will be used as an offset. Such mechanisms will be product and brand neutral, and the collection will not be confined to the packaging of the producer or brand owners. Products only and can be carried out in any locations of their choosing. The way, no segregation, no pollution, no landfill, low energy, low cost, low human interaction, decentralized, no transportation, disposal at source. Thermal decomposition of organic matter. Optimum degradation temperature. Organic matter can be decomposed at elevated temperatures, without the addition of external energy, under controlled air/fuel ratio. Principle of operation. Organic thermal decomposition starts with the application of heat, and a controlled positive feedback is created, producing a thermal runway. Adding magnetized air and heat to atomic conditions, it is possible to separate electrons. Under the condition of closed magnetic heat, electron accelerates from the separated atoms. Negatively charged electrons and positively charged nuclei constantly interact with each other and form a plasma state. It gives off heat in the process. Around 200 degrees Celsius temperature is required to accelerate the reaction, which in turn increases to 300–500 degrees Celsius by the oscillation of atoms and electrons in the molecular level. The electrons infiltrate the treated organic molecules and break carbon and hydrogen from the long chain and tear the molecular chain. then spreads rapidly around. It forms a pyrolysis field with great energy. Organic substances become ash. Magnet and air. Most gases are slightly diamagnetic and repelled out of a magnetic field. Oxygen is different. It is a paramagnetic gas due to non-paired electrons, which means that it is attracted by a magnetic field. Out of a ceramic tube, a wind of velocity 1 meter per second is generated, while no wind is detected. In the absence of the magnetic field, due to the paramagnetic nature of oxygen, this effect is achieved. The oxygen molecules became active in nature. Air-fuel ratio. Fuel in the form of biomass, organic materials, etc., are loaded from the top. Ambient air is passed through strong magnetic field and accelerate the oxidation process, helping continuous exothermic reaction. The air/fuel ratio is kept at 1.2 and an equivalent ratio of 0.2 is maintained using control valves. Operation. In the first layer, raw garbage is dumped inside, through the top door. In preheating layer, garbage descend into second layer where moisture of the waste evaporates due to the heat. In decomposition layer, the refuse emits dry distillation gases and gets carbonized. The carbonized matter is further reduced to powder-like residue, ash. In the last layer, final residue, a powder-like ash gets accumulated. The stabilization period is 10 to 20 days depending on the type of waste. Mass and energy flow. Flue gases will be treated to meet air pollution standard. With fewer modification, wasted heat can be recovered to generate hot water or can be used for any other heating applications. The remains are inert ash which can be used in brick making/landfilling. All inorganics will not be destroyed, the same can be separated and sent for material value recovery. Coal tar is being generated with liquid and after desiccation it shows good calorific value, which means it can be used as profitable fuel. When wood/plant-based waste is decomposed, the derived liquid can be used as an herbicide after proper testing and evaluation. Mass and energy balance is as explained in the diagram. Diagram explains the air pollution control. Pollution measurement values are as shown in the figure. The process is compatible to the norms and standards prescribed by the central and state pollution control boards. The flue gas generated during the decomposition process will be treated as per discharge norms. Decomposition of 1 ton of municipal solid waste produces 442 cubic meters of landfill gas, containing 55% methane. The US EPA listed 94 non-methane organic compounds found in air emissions from municipal solid waste landfills. Landfills contribute 20% of the total global anthropogenic methane emission. Emission of dioxins from different sources are as explained in the diagram. Mechanism of dioxin formation. The first mechanism is the incomplete destruction of CDDs, CDFs, contaminants present in the fuel or feeds. Not all of these molecules are destroyed by the combustion system, thus allowing trace amounts to be emitted. The second mechanism involves the formation of CDDs, CDFs from aromatic precursor compounds in the presence of a chlorine donor. The third and last mechanism, de novo synthesis, promotes CDDs, CDFs formation in combustion processes from the oxidation of carbon particulate catalyzed by a transition metal in the presence of chlorine. Reduction of dioxin formation. It is found from a basic research, under electron beam irradiation, the decomposition of dioxins can be occurred due to 1. Scission of the ether connection, 2. Cleavage of the benzene ring, and 3. Removal of the Cl atoms. A decomposition ratio of 80% was achieved at a dose of 10 kg and 90% at 15 kg of electron beam irradiation. By adding magnetic air and heat into atomic condition, it is possible to separate electron from atom. Separated electron and atom can stay as unstable plasma state. The separated electron change to accelerated electron with strong energy. This special space configures and keep critical balance of oxygen and make unstable and activated atomic oxygen by breaking atomic bond of oxygen molecule. This accelerated electron and active oxygen can decompose dioxins. Key features. Needs no segregation. Requires no power/fuel to destroy waste. The process is exothermic, low temperature, 350 degrees Celsius to 400 degrees Celsius, thermal decomposition. Massive volume reduction. 1/300 times of original. Meets Indian air quality standards for flue gases. Needs no skilled manpower. Low cost of operation. The end product will be inert ash, needs no treatment to dispose. Small footprint. Example, requires 20 by 20 ft2 for 250 kg/day machine. Moisture content should be less than 40% for optimum destruction. Decomposes the waste in 6 to 8 hours in batches and the machine can run continuously. No moving parts and works at low temperature. Extremely robust and durable. Incineration versus Viridé. The capital investment is very high. Operation cost is INR 1,200.00 per ton. For incineration, and for Viridé capital cost is lesser as small decentralized units are feasible. Operation cost is INR 400.00 per ton. Endothermic reaction. Requires enormous power/fuel to destroy waste. For incineration, and for Viridé it is exothermic reaction. Requires no power/fuel to destroy waste. The fly ash is toxic in nature and needs special treatment before disposal. For incineration, and for Viridé the residue/ash is inert and can be used for brick making. The total volume of ash is 1/300th input. According to UNEP, the incineration plants are one of the largest GHG emission plants. For incineration, and for Viridé the exhaust gas is treated and meets PCB Indian standards. Very complex system with lots of moving parts. Needs regular maintenance. For incineration, and for Viridé no moving parts and works at low temperature. Extremely robust and durable. Needs skilled operators to run the plant. Workers are exposed to hazardous working environment. For incineration, and for Viridé need no skilled manpower. Full automation can eliminate human interaction. Autoclave versus Viridé. For autoclave it does sterilization only. The end product must go to landfill or any other secondary process. And for Viridé the residue/ash is inert and can be used for brick making. The volume reduction will be 95%. For autoclave it works under heat and pressure. Source of heat is steam which consumes huge power. And for Viridé it is exothermic reaction. Requires no power/fuel to destroy waste. The capital investment and operation cost is INR 6,000.00 per ton. For autoclave and for viride, capital cost is lesser as small decentralized units are feasible. Operation cost is Rs 400.00 per ton. The process can aerosolize chemicals present in the waste and that can pose a hazard to operator. For autoclave and for viride, all the flue gases will be released after treatment meeting CPCB norms. For autoclave it is batch process. Loading, pre-vacuum heating, sterilization, cooling, draining, unloading. And for viride it is a continuous destruction process with batch loading. For autoclave need skilled operators to run the plant. Workers are exposed to hazardous working environment. And for viride need no skilled manpower. Full automation can eliminate human interaction. Efficacy. Theoretically, all kinds of organic matters including plastic products, paper, plant straw, rubber products, animal bodies and excrements can be completely decomposed. Freshwater animals and plants with moisture contents more than 35%. Kitchen wastes can't be decomposed until they are combined with other organics with less water or desiccated first. When the combination of organics and inorganics are decomposed, the organic parts turn to ashes and inorganics including metal and glasses can be separated and reutilized. Inorganic material, metal, glass, ceramics, liquid and fluid container etc. cannot be decomposed. Taking electric appliance as an example, after the pyrolysis of cell phones, computers, batteries, tires etc., organic parts turn to ashes, while the metal wire, skin and fiberglass still remain. Destruction for fuzz waste. Fuzz are a broad group of compounds that have unique properties which have resulted in their widespread use in industrial, commercial and consumer applications and products. Fuzz chemicals may cause adverse health effects, including immune system or thyroid effects, and changes in cholesterol. Research shows thermal treatment technology is suitable for fuzz destruction. A trial on fuzz impacted soil in 2019 that demonstrated 99.999% destruction of 24 fuzz. Conventional thermal treatment consumes huge energy. Low-temperature thermal destruction, being a self-destruction method, is the solution to end the fuzz issue permanently. Case Study 01. Sludge disposal. ETP/STP sludge contains concentrated pollutants like fuzz, residual drugs, hormones etc. It is very dangerous to dispose without treatment. Organic sludge/waste can be destroyed using viride. The continuous exothermic reaction is an excellent source of thermal energy. Sludge disposal can be an energy-neutral or positive energy process. Heat can be captured from the flue gas and used for different purposes like inorganic energy input for sludge dryer, steam generation etc. A dry inorganic hazardous sludge can save 20 to 30% on disposal cost. Case Study 02. 27% of the mixture consists of ingredients of unknown acute oral toxicity. The specific chemical identity and/or exact percentage, concentration, of this composition has been withheld as a trade secret. Specific industrial waste which cannot be destroyed/recycled can be thermally decomposed without spending energy and creating pollution. Material of economic value can be recovered from the ash. Where we can make some difference. Apartments, institutions, shopping malls, movie theaters, hospitals, military bases, parks, workshops, ships, villages, beaches, islands, railways. Economics. Disposal cost is in the range of Rs 5.00 to Rs 8.00 per kilogram. Issues with existing practice: irregular collection, improper treatment, spillage, collection workers are exposed to the waste. Treatment cost is under Rs 400.00 per ton. Only landfill tipping fees are in the range of rupees 400.00 to rupees 800.00 per ton. The cost for leachate treatment is in the range of rupees 600.00 per cubic meter. Medical expenses for the disease and death tolls due to air pollution caused by hazardous gas from landfill. Few of our clients are Government of Arunachal Pradesh, Engineer Regiment, Indian Army, Land Ports Authority of India, Government of Andhra Pradesh, Ikakalpakkam, E-Waste Social, Bengaluru, Numaliga Refinery Limited. Awards we won include Bangkok Business Challenge 2021 in association with Hong Kong Baptist University under the name of Team We They. The team was awarded first runner-up among 242 entries across the world for the idea of decentralized biomedical waste disposal using low-temperature thermal destruction process. Plastic Fry, a team from KTH Royal Institute of Technology, Sweden, was awarded winner in this 3-month-long global sustainable business competition. Who are we? Water treatment plants, healthy water devices. Waste, solid waste disposal, waste management. Air quality monitoring, air disinfectant. Energy, waste to energy optimization. Automation, industrial material handling. We are extremely thankful to you for your interest and time. From Team We They and Adstock Global Technologies Private Limited, Bangalore.